Welcome to this video. So in this video we are going to talk about disaccharides. So from the word di, as you can see, di means two. So disaccharides are just sugars made up of two sugar units, which we call biologically monomers. So characteristics of disaccharides. So these sugars here, they are crystalline. They are crystalline, which means they are crystal-like. They make crystals. So the other one, they are sweet to taste. Sweet to taste. Not only that, they readily dissolve in water. They dissolve in water. So the process that we call condensation. Formed by condensation. So this means that when you join two monomer units, you are going to release a water molecule from the two monomers. Two monomers joined to release H2O, water. So the bonds that joins the two monomer units joined by a glycosidic bond. So don't just be intimidated by the word glycosidic bond. So a glycosidic bond is just a bond that has oxygen atom in between, like this. So you can have a monomer here represented by R and another monomer 2 which is represented by this. So this is what we call glycosidic bond. Glycosidic bond. Let's go to the next thing. So the disaccharides are just a temporal storage form of sugars. Used to store sugars temporarily. And this means that they can be broken down anytime. So they are broken down down by hydrolysis. Sorry, this is hydrolysis here. Made a mistake on the writing. So it has to be hydrolysis, meaning you break using water. Remember when we talked about the formation of disaccharides, we said there is a release of a water molecule. So when that water molecule that is lost when you are forming disaccharides, when you add it to the disaccharide that is formed, that means you are going to get back to what we call the monomers broken down by hydrolysis, which means addition of water. So the most common disaccharides are sucrose, then the next one is lactose, and the lastly but not the least we have maltose. So let's look at the sucrose now. So let's look at sucrose, the structure of sucrose. Sucrose. So sucrose is the sugar that found in cane. So this is just cane sugar. So this one is just made up of glucose and fructose. So these are just joined by 1,2 glycosidic bond. Glycosidic bonds. So at carbon 1, C1 of alpha glucose and carbon number carbon number 4, number 2 I mean, of beta fructose. So we discussed these structures in monosaccharides, the structures of alpha glucose and beta fructose, where you find for beta the hydroxyl group, you find it above the ring structure. So its molecular formula for this thing, sucrose, is just the same as that of. So the formula for this one is C. You have C12, then we have H22, you have 22 hydrogen, and oxygen, you have 11 oxygen. So let's see now the structure for this structure here and how the condensation reaction happens. So we have this alpha glucose here. So we have H here, we have CH to OH here, then here, sorry, here it was supposed to be O here. Yeah, so here it's supposed to be oxygen here. So we have H here, we have OH here down, then we have OH here. So we have OH here, then here we have an H here, here we have OH, here we have H, here we have H. So as you can see, this is carbon 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5 here, and this is carbon number 6 lastly. So as you can see, this is the structure of glucose. So since this hydroxy group here is down, so we're going to say this one, this is alpha glucose. This is alpha glucose. Then plus, let's draw the structure of fructose. So fructose, we say it is a furanose ring. It forms a furanose ring. So this is a furanose ring. We have here, we have here. So we have H to OH here. Then we have H here. Then we have H here. We have OH here. Then we have OH again here. We have H here. So we said this is beta. So for beta, you start with the hydroxy group at the top here for beta. So this is the structure of fructose. So this is beta fructose, beta fructose. So this reaction is actually a reversible reaction. That means it can go. So this can go this way or go back here. So this one didn't write it properly. So let's do a minus. Let's put alter here. So we put minus H2, then here we put plus H H2O. So when we put minus here, that means we are releasing water molecule. This is dehydration or condensation. But when we add the water here down, H plus H2O, so that means we are doing hydrolysis, we are breaking down. So let's now see the structure of the sucrose. So we have the structure of glucose here. So we have oxygen here. Then so let's also draw the structure of fructose here so that we join the glycosidic bond. So the glycosidic bond will be like this. This is the oxygen, like this. So we have the H here, and here we have 2OH, and here we have H. Here we have CH2OH. Here we have OH. Here we have H here. We have H here. We have OH here. Lastly, what else do we have? So we have here, we have H here, we have OH here, then we have OH here, we have H, CH2OH, and we have the H here, then here we have the H, we have the OH. Yeah, so as you can see, this is carbon 1, and this is carbon 2. So this is the structure of sucrose. So in the structure of sucrose, you just join an alpha glucose and a beta fructose. So the bond is 1, 2 glycosidic bond. So this is the bond that joins the sucrose, 1,2 glycosidic bond. So when you add water, that means that is hydrolysis. You come back to the monomer units. But when a water molecule is released, when you join two monomers, that is what we call condensation. That means you form now the disaccharide. Thank you for watching this one. So the next video we're going to talk about the formation of lactose as part of the disaccharides. This is once done. Thank you for watching the video.